Okay, so I think at this point we have a pretty good idea of how the painting works. We initialize the graphics data, which we've seen before with all this business, getting our dimensions and setting up our pixel size and center of the screen and all that. And then we draw the drawing rectangle, which is that, let's see, let me create it, that the drawing rectangle is just this rectangle here, right? So all the drawing is supposed to happen inside that. Then if we have more than one vertex, or if we have more than 0 vertices, if we have any vertices, then we try to draw a polygon. And the way that works is first we draw the tiny rectangle, then we loop through all the points and go from from point to point. And if we've clicked in that tiny rectangle again, then we, rather than drawing exactly the last point clicked, we draw to the first point in order to make sure the polygon's closed. And if that's not completely clear, we're going to do a little more work that might make that more obvious. Because what I want to look at next is this kind of obscure test here to see if we've clicked inside the tiny rectangle. So you see this. We have something squared, right? Dx times itself plus dy times itself. So something squared plus something squared is less than, and it almost looks like this is something else squared. So it might make you think of the Pythagorean theorem, and if it did, that would be a good thing. Because what's going on is, let's say this was our first click here at x0, y0, right in the center of this tiny box. And I've drawn a circle in here because really what we're testing is to see if we're inside this circle. And I'll demonstrate that a little better pretty soon. But what's happening is we have this, we get our dx from xa minus x0. So here's xa, ya, right? So if xa is here and x0 is here, then xa minus x0 gives us this length dx, right? And similarly, ya minus y0 is going to give us this dy. Remember, these are logical coordinates we're talking about now. So, x and y behave the way you would expect them to in a normal coordinate plane. So what do we have? Well, we know then, right, if this, from this, if we draw a straight line from x0, y0 to xa, ya, that's a radius of the circle, right? And we also know that since this is a right triangle here, we know that dx squared plus dy squared equals this radius squared, right? Dx squared plus dy squared equals radius squared. And we know that the length of the radius from here to here is going to be the same. If it's a radius, then the length from here to here is the same as the length from here to here, right? So the actual radius is going to be 2 pixels long, or 2 times whatever the pixel size is, right? So we have another way of saying that is dx squared plus dy squared equals this 2 times the pixel length, right, which is our radius, squared, since the radius is 2 times the pixel size, right? So if we square that, we get 2 times pixel size times 2 times pixel size, or 4 times pixel size. So that's where you get this weird stuff here. So you have this, basically this is dx squared plus dy squared equals 2 times the pixel size squared, which is 4 times pixel size. Okay, so now let's see if we can write that a little bit more nicely here. Let's go here. I think the first thing I want to do is just kind of pull all of this out into another method that returns a Boolean. Let me see if I can just extract it right from here. Well, let me refactor, introduce method, and let's call it is inside tiny rectangle. So we're just going to test to see if it's inside the tiny rectangle. And let's just check here. So we're passing it dy dx. Yeah, it's returning that. Let's just make these numbers a little bit clearer. So how about we introduce another method here called square. So I'm going to say square dx instead of x dx times dx. And it's going to complain because there's no such method. So let's create one here. And we'll call it, we'll just say x here, and then we'll say return x times x. I'll make this comment. Okay, so that's going to, because that's what squaring does, right? And then let's do, oops, square y, or square dy, I mean. And then let's square 2 times the pixel size. Oh, but we know we have a final static variable here called half tiny side, right? And that's really what we're talking about. We're talking about that 2 really stands for half the length of the side of the tiny rectangle. So let's use that, and then what we can do to just make sure we're make a little clearer what's going on, we can kind of experiment here. So let's go down to where we're drawing the tiny rectangle, and let's actually, there's a method called draw oval that works pretty much the same way, I think, as rectangle. Let's see. I think we can just say draw oval, and it'll draw a circle inside, with that radius. Yeah, it'll draw a circle that fits inside that rectangle. So I have the radius that we're looking for. So now what we could do is actually make this tiny side considerably bigger. We could make it, I don't know, let's make it 100, see what that looks like. And then we can see not only our triangle, oh wait, we're going to see not only our rectangle, but also that circle inside it. So I'm going to go here, I'm going to click, and see now, because I did that draw oval, we can see the circle inside there. So if I click over here, see for vertex goes straight from here to there. But notice if I click out inside the rectangle but outside the circle, it just sees that as just another point. So I have to be inside the circle. But now I'm going to click inside the circle. I'm not right at that point, but if I click anywhere inside the circle, notice it goes right back to that first point. Okay, so given the analysis that we had so far, that should make some sense. And now we can, just start another one like that. Okay, and then if we just set this back to 4 and just comment out our drawing the oval because we don't need that anymore. But I'm just commenting it because I might want to do some more testing later on with that. And let's run and just make sure we're back to where we started. Yeah, that looks right. And if we're in there, yep, that works. Doing a single line works, and a single point, that works. Okay, so looks like we've pulled that out. So that helps clarify now what's going on at this point. If that point is inside a tiny rectangle. Actually, you know what? There's one more thing I would like to do here. I think it makes more sense, instead of passing the dx dy, if I pass the xa ya here. Because I don't need that dx dy anyplace else, do I? No. So let me just copy this to here, and copy this to here, and cut this, and go down to my what do I call it? Draw a polygon. No, I can't find it. Oh, here it is inside tiny rectangle. Let me just move this here and make this be XA and make this be YA. Yeah, I think that makes more sense. Okay, so now that that float business is entirely inside here. So if I come up here, it just says, yeah, if ready, do that. If is inside tiny rectangle, do that. Okay, so that looks good. Oh, and just again, as always, double check. I'm going to leave this. This is something you always want to do, is make sure you're covering your bases and testing.